So class, our topic is balancing ionic reactions. Class, it can be studied under three heads: balancing ionic equation in acidic medium, then basic medium, and the third one is balancing disproportionate reaction. What are disproportionate reaction? Once we are taking the case, I'll let you know what is disproportionate reaction. But there are three ways to balance an equation. First, acidic medium, second, basic medium, and third is the disproportionate reaction. Class, we'll first take balancing equation in acidic medium. Class, for that, we have to learn the steps. So class, I am going to write here all the steps. You must note down in your register one by one. Step number 1, identify the species undergoing oxidation and reduction. Step number 2, find their respective change in oxidation. Step number 3, divide the reaction in two ionic half reactions, that is oxidation reaction, and the second one is the reduction reaction. Cross multiply the change in oxidation number. Add. Why we are cross multiplying the change? To balance number of electrons taking part. And the last step, balance O by H2O and put double H positive on the opposite side. So these are the steps, and you must note down in your register because you will forget it. Once you have noted down, you will remember it. I repeat again. Identify the species undergoing oxidation and reduction. Find their respective change in oxidation number. Divide the reaction in two ionic half reactions. First one, oxidation reaction. Second one, reduction reaction. Cross multiply the change in oxidation number. Why? To balance number of electrons taking part. And the last step, balance O by H2O and put double H positive on the opposite side. So class, we are going to take here some examples on acidic medium. Question is, balance the following. Cu plus nitrate giving me Cu2 plus NO. And the medium is given to us acidic. Identify the species undergoing oxidation and reduction. Class, remember, I have already told you that increase in oxidation number is oxidation and decrease in oxidation number is reduction. If you remember your class 9-10 differences, that combination with O and removal of H, you never find mention here of is neither combining with O. So forget all those things. Now you should concentrate only on two things. Increase in oxidation number is oxidation and removal of electron is oxidation. Similarly, decrease in oxidation number is reduction and acceptance of electron is reduction. So class, let us find it. Class, we find here copper not combining with anybody. So oxidation number here is 0. Atomic state not combined. Valence is 0. Therefore oxidation number 0. And here what we find? Plus 2. So copper is moving from 0 state to +2 state, therefore oxidation of copper is taking place. Now class, in nitrate, neither there is peroxide bridge and neither here peroxide bridge. So in both the cases that oxygen is sitting at -2 state. So obviously nitrogen is going to be reduced. How? Just see. We'll make a bridge to understand the thing. Class, nitrogen is X, oxygen -X, because -2 into 3, and this must be equal to what? -1. So X minus equal to -1, X equal to +5. So nitrogen is sitting here at +5, and if oxygen is -2, then nitrogen is +2. So very simple class. Nitrogen is moving from +5 state to +2 state, +2. Therefore, decrease in oxidation number taking place. So nitrogen is going for reduction. So class, we have completed our first step. Identify the species undergoing oxidation reduction. We have already identified copper is going for oxidation and nitrogen is going for reduction. Now step number 2, find the respective change in oxidation number. Let us find it out. If copper moves from 0 state to +2 state, it means the change of 2 electrons, means it is removing its 2 electrons. Remember, very important, going for oxidation, so removing 2 electrons. It is going for reduction, and reduction means what? Acceptance of electron. So by how many units? It is +5 and this is +2, so the change is by 3 units. So we have completed our second step also, find the respective change in oxidation number. Now divide the reaction into ionic half reactions, oxidation and reduction reactions. Class, copper is going for oxidation, so you see how to write copper, giving me copper 2+, and as I have already said that oxidation means removal of electron. How many electron will be removed? 2. Similarly, nitrate going for reduction, giving me what? Giving me NO. But what is the change? 3 electrons. So you see, oxidation reaction, removal of electron. Reduction reactions, acceptance of electron. So we have completed our third step also. Now the fourth step, cross multiply the change in oxidation number to balance number of electrons taking part. Now you see, copper is giving 2 and nitrogen wants 3. So to balance electron, what we do, we cross multiply. We multiply it by 3 and I multiply here by 2. Why 3 and 2? Because copper is removing 2 electrons, so I have put here 2, cross multiply. Nitrate is accepting 3 electrons, so I have taken here 3. Class C, if I multiply 3 by 2 gives me 6, and 2 multiplied by 3 again gives you 6. So number of moles of electron taking part will be equal. So now the reaction will be going for balancing. See, 3 copper giving me 3 copper 2 plus 6 electron, multiply by 2 nitrate plus 6 electron giving me 2 NO, add 6 electron gone, 3 copper plus 2 nitrate giving me 3 copper 2 plus 2 NO. At this stage, all our oxidant and reductant are balanced. See how? 3 copper, 2 nitrogen, 6 oxygen. But oxygen remain unbalanced because oxygen was not taking part in oxidation reduction. So oxidant and reductant are balanced. 3 copper, 2 nitrogen, 2 nitrogen. Now see what the last step says. Balance O by H2O and put double H positive on the opposite side. Class, how many O here? 6 O. How many O here? 2 O. So if I write here 4H2O, see, balance O by H2O. So if I write here 4H2O, then oxygen getting balanced. 2 and 4, 6. And the next step what it says, put double H positive on the opposite side. How many water molecule here? Put here 4. So 4 double is 8. So I'll just put 8 H positive here. Students, the reaction is already balanced. See, 8H, 3 copper, 2 nitrogen, 6 oxygen, 2 and 4, 6 oxygen. So class, atoms are balanced, but you are supposed to find out whether your charges are also balanced, because unless your charges are balanced, the reaction is not balanced. So let us find it out. Class, how to find the charges? See, one H atom contains one positive charge, so 8 will contain 8 positive charge. No charge here. Let us move here. One nitrate contains one negative charge, so 2 nitrate will contain 2 negative charge. So overall, how much I am getting? I am getting 6 positive charge on the reactant side. No charge here, no charge here. One copper has 2 positive charge, so 3 copper will have 6 positive charge, 6 positive here and 6 positive there. Therefore, the reaction is balanced. So class, this way the acidic medium reactions are balanced. Class, I repeat the entire thing again. As soon as you get for balancing, identify the species undergoing oxidation reduction. With the help of our oxidation number in mind, we can very well say that copper is going for oxidation, removing 2 electron, nitrogen is going for reduction, accepting 3 electron. In the next step, we have divided the equation oxidation reaction, reduction reaction. Oxidation reaction, we found that 2 electron were removed, and reduction reaction, we found that 3 electrons were being accepted. So the electrons are not balanced. One is giving 2, other one is accepting 3. If it would have been 2 here, then there was no need of cross multiplying, because 2 electron will balance. But in this case, it is 3 electrons, so we'll have to multiply. Cross multiply. So if I cross multiply, we get 3 copper, 3 copper 2 plus 6 electron, 2 nitrate plus 6 electron, giving me 2 NO. Now add both the reactions. Once both the reactions are added, 6 electron get cancels. So 3 copper, 2 nitrate, giving me 3 copper 2 plus 2 NO. So 6 oxygen were there. There were only 2. So balancing to balance O, I put here 4H2O. So 6 oxygen balance. And what is the value here? 4. 4 cuttable is 8. So I'll put here 8 as positive. And now my entire reaction get balanced. So this is the way acidic medium reactions are solved. We'll have one more example here. Dichromate reacting with ferrous, giving me Fe3 plus Cr3 plus. And the medium is again acidic. Class, you can very well recognize that iron is going for oxidation, moving from +2 state to +3 state. So we got the first one, iron moving from +2 to +3, changed by 1, undergoing oxidation. Class, there is no O here, it means O is not taking part in redox reaction, so we'll have to concentrate on Cr. So let us find out oxidation number of Cr here. Class, you know very well, 2x minus 14 equals to minus 2, because 2 Cr are here, so 1 Cr is x, so 2 Cr is 2x, because oxidation number is always calculated per atom. So 2x minus 14 equals to minus 2, so 2x equal to 12, x equal to +6. So class, chromium is sitting here at +6, and here chromium is sitting at +3. Very, very important line to understand here. Class, how many Cr were there on the reactant side? But how many Cr on the product side being seen? Only 1. As per Dalton's atomic theory, atoms can neither be created nor be destroyed. So if 2 Cr were present on the reactant side, then definitely 2 Cr will be also there on the product side. I cannot put Cr here too. Whatever you want to do, you'll have to put it here only. You cannot change the formula. So class, now 2 Cr here, 2 Cr here. Listen again. 1 Cr is moving from +6 state to +3 state. Reduction taking place by 3 units, but it is not 3 units, it is by 6 units. Very, very important. I repeat again, why? Plus oxidation number is calculated per atom here. In Cr, you have calculated your oxidation state here +6 for 1 Cr, and here +3. So 1 Cr is moving from +6 to +3, means 1 Cr is consuming 3 electrons. But how many Cr were present in the formula? So both of Cr are going to react. So if one CR changes by 3 units, then both the CR will be changing by 6 units. And as soon as you get here CR2, you must put here 2 CR. Because number of atoms should be balanced. So now class, it is very clear. Iron is going for oxidation and chromium is going for reduction. This step is very crucial step, class. Most of the students lose it and ultimately they get their reaction cancelled. I repeat again, since there were 2 CR in the formula, so we'll have to take total change taking place on CR. One CR was moving from +6 to +3, but there were 2 CR, so I should multiply by 2 to get here 6. And as soon as I multiply by 2 here, I'll put 2 CR over here. Class, it would have been 4 here, then I should have multiplied by 4 here, and I should have written 4 here. But since it is 2, so we have taken twice. Now class, next step, divide the reaction into ionic half reactions. So Fe plus 2 giving me Fe plus 3, removing 1 electron. Dichromate, Cr272 negative, consuming 6 electron to give me 2 Cr3 plus. This is giving 1, this is requiring 6. So if I multiply this by 6 and this by 1 means you have to do nothing. So I'll get my total electrons 6 over here. So in the next step I am going to write 6 ferrous giving me 6 ferric plus 6 electron, and dichromate consuming 6 electron to give me 2 Cr3 plus. 6 electron got cancelled. I'm writing it Cr272 negative plus 6 ferrous giving me 6 ferric plus 2 Cr3 plus. Class, I've already told you, when you just add the reactions, your oxidant and reductant both should get balanced. See here, 2 Cr, 6 iron, 6 iron. So oxidant and reductant both are balanced. Now I have to balance O. How many O here? 7. So to balance 7 O, I'll put here 7 is 2 O, and 7 per double is 14 at positive. So I'll put here 14. Plus my reaction is balanced. See how? 2 Cr, 6 iron, 14 H, 7 to the 14 H, 7 O, 7. So atoms are balanced. Now let us find out their charges. 6 to the 12 positive, 12 and 14 positive, 26 positive, 26 positive minus 2 gives you 24 positive. Charges on the reactant side, I repeat again, 6 to the 12 positive, 14 positive, 12 and 14 gives you 26, and 26 positive minus 2 will give you 24 positive. Now class, see here, 6 is 18 positive and 2 is 6 positive, 18 and 6 gives you 24 positive. Class, both sides the reaction is balanced with number of atom also as well as charge also. So class, this is the way you balance the ionic reaction in acidic medium.